Good morning, students. Now this is the last session for magnetic materials. So in the last class we have completed Curie law and Curie West law, and next we come across magnetic hysteresis. So whatever the things we have studied in the magnetic material, we want to bring it for the application. That application of the whole topic is nothing but here magnetic hysteresis. With the help of the magnetic hysteresis, we come across selection of the magnetic materials, that is to making the permanent magnet, and electromagnets, that is temporary magnets. So next one, magnetic hysteresis. Magnetic hysteresis. Then what is that hysteresis? Now this is the Greek word. The hysteresis is the Greek word that means lagging behind. So, the magnetic hysteresis is the term behind lagging behind the one magnetic component with another. So, when you take the ferromagnetic substance for the cycle of magnetization, the intensity of magnetization lags behind the magnetizing field, and the phenomenon is called magnetic hysteresis. When you take the ferromagnetic substance for the cycle of magnetization, the intensity of magnetization lags behind the magnetizing field, and the phenomenon is called magnetic hysteresis. So, what is the cycle of magnetization? Cycle of magnetization is nothing but making the material to be magnet and demagnet. How it is possible? By taking the material, ferromagnetic material, in the core of what? Solenoid. So I take the simple circuit diagram. So this is the solenoid. Unless until to pass the current through the solenoid, it doesn't act as a magnet, key, battery. I pass the current I, small I. So I want to reverse the direction of the current. For that I have the device that is called Commutator Four-Way Key. Usually use what in the laboratory? Two-way key. This is commutator which is used to reverse the direction of the current. As the direction of the current reverses, the magnetic field is also reverses, because in the solenoid B equals to mu naught Ni, B is directly proportional to current. As the direction of the current reverses, the direction of the magnetic field is also reverses. So now this is the rheostat. I take the ferromagnetic substance in the core of solenoid. Unless until to pass the current, it cannot act as a magnet. When the solenoid is act as a magnet, then the material which is kept inside the solenoid, that acquires the magnetic properties. We know that how easily the material should be made magnetized, that measures its susceptibility. So, as the intensity of magnetization increases, there is a increase in what? The magnetizing field. When I take the ferromagnetic substance in the cycle of magnetization, there is a variation of intensity of magnetization with respect to what? Magnetizing field, and it is represented with the help of what? Graphical representation, that is called magnetic hysteresis graph or magnetic hysteresis curve. With the help of magnetic hysteresis curve, we can select the materials for the different purposes to making the permanent magnet and temporary magnets. So, I represent the cycle of magnetization with the help of what? Magnetizing field H and intensity of magnetization I. Now this is origin. When a ferromagnetic substance is taken through a cycle of magnetization, there is a variation of intensity of magnetization with respect to what? Magnetizing force, and it is represented graphically, and the graph is known as magnetic hysteresis curve or magnetic hysteresis graph. Before applying the key, there will be no flowing of the current, 0. As the current is passed, H equals to Ni. As I increases, H increases. As H increases, the intensity of magnetization is also increases. That is nothing but I is directly proportional to H. I equals to magnetic susceptibility into H. Then magnetic susceptibility equals to I by H. Now made the definition. The magnetic susceptibility is the ratio of intensity of magnetization to the magnetizing force or magnetizing field. So I is directly proportional to H. H is directly proportional to I. This much is sufficient. I can write. Hence, आपको understanding करने के लिए I is directly proportional to H, directly proportional to I. Equation basis जो already theory पर है, उसको अच्छे तरह से use कर लो. Then, as I increases, the magnetizing field is also increases. As I increases, so H increases. As H increases, the intensity of magnetization is also increases. It reaches to the maximum A. Every metal has got its capacity to become what? Magnet. It is fully magnetized. Then, even though you are passing the current, even though you are making the solenoid to be magnet, it does not acquire some magnetic property further. So it maintains constant, saturates parallel to x-axis at point A. The material becomes what? Fully magnetized, and it becomes what? Saturated. As H decreases means the decrease of current. As the current decreases, the H is also decreases. As H decreases, I also decreases. As H decreases, I also decreases. At a particular value of H, the I does not becomes 0. Here H is 0, but OB indicates what? The value of I. And this is an important factor. Even though the magnetizing field is made to be 0, the intensity of magnetization is not 0. Still the magnetic property in the material is left. Now this is called residual magnetism. And this phenomenon is called here retentivity. The retentivity is the property by virtue of which, as a magnetizing field is 0, the intensity of magnetization is not 0. And that property of the material is called retentivity. So this is retentivity. Still the magnetic property is retained in the material, even though magnetizing field is made to be 0. The virtual property by which the intensity of the magnetization is still left, even though the magnetizing field is made to be 0, and that property of the material is called retentivity. Whatever the magnetic field is left in the material, even though magnetizing field is made to be 0, I want to vanish it. I want to make the material to be completely demagnetized. I want to be residual magnetism should be made to be 0. Then I have to go in the reverse direction. In this position, there is the existence of the value of H, but I is 0. So initially I kept the key. Always the commutator works in the opposite direction. Here the key initially. Now up to this. I want to reverse the direction of the current. As the direction of the current reverses, magnetic field is also reverses. The value of H is also reverses. As the direction of the current reverses, so the magnetizing field is also reverses. I place the commutator here. दोनों के यहाँ पे रख दूँ मैं. Then the direction of the current is reversed. As the direction of the current reverses, H reverses. So, by applying the negative H, negative value of the magnetizing field, as H increases towards the negative, I decreases. At a particular value of H towards the negative side, the intensity of magnetization becomes 0. Whatever the magnetic field is left in the material, that is made completely 0 by applying the negative magnetic field. By applying the reverse magnetic field, the intensity of magnetization is made to be 0, and this is called coercivity. One is the retentivity, another one is coercivity. Whatever the magnetic field is left in the material, whatever the residual magnetism is left in the material, that should be made to be 0 by applying the magnetizing field in opposite direction. And this is called coercivity. And these two terms plays very important role while selecting the materials for making permanent magnet and electromagnets. Right? If I increase the value of I in opposite direction, as H increases, I also increases and it reaches to the maximum in opposite direction, saturation, and the phenomenon is repeated again and again, and this is called a complete cycle. जो कुछ भी यहाँ पे था वही रिपीट हो जाता. Now this is called hysteresis curve. This is nothing but hysteresis loop. By calculating the area enclosed, we can select the material for making the permanent magnet and temporary magnet. The area of the loop is less than such materials are used for making electromagnets. So this is about retentivity and this is about coercivity, and this cycle is called hysteresis loop or hysteresis curve. But what are the two important terms? One is retentivity, another one is coercivity. What is that retentivity? Even though by making the magnetizing field 0, H0, the intensity of magnetization is left in the material and it is called retentivity. Whatever the magnetic field is left in the material, that is I, that is made to be 0 by applying the magnetic field in the reverse direction, and that property of the material is called coercivity. By knowing the graph and its calculating the area, we can select the material for making the permanent magnet and temporary magnets. Now this is the importance of what magnetic hysteresis. Here the intensity of magnetization is lags behind the magnetizing field. Hence it is called magnetic hysteresis. The intensity of magnetization lags behind the magnetizing field. Hence the phenomenon is called magnetic hysteresis. Hysteresis means the Greek word lagging behind. Here I lags behind H. Right? Now this is about what? Magnetic hysteresis. Then by using this magnetic hysteresis curve, by knowing the area enclosed under an IH curve, we can select the materials for making the permanent magnet and temporary magnet. So one is permanent magnet. Permanent magnet, and second another one electromagnet. The permanent magnet is one which retains the magnetic property even though in the room temperature for the long period. What is that permanent magnet? A ferromagnetic material which retains the magnetic property for the long time even though at room temperature is known as permanent magnet. To make the permanent magnet, we take the what? Soft iron rod and placed inside the core of the solenoid, and the current is passed through the solenoid, then it acts as a permanent magnet. A rod of ferromagnetic material is placed in the core of what? Solenoid. When the current is passed through it, then it acts as a permanent magnet. A ferromagnetic material which retains its magnetic property for a longer period even though at room temperature is known as permanent magnet. How the permanent magnet is going to be obtained? A ferromagnetic rod is placed in the core of the solenoid and current is passed through the solenoid, then it acts as a permanent magnet. Then what are the properties belongs to permanent magnet? To have the permanent magnet, what are the things to be required? So first one, relative permeability. Second one, retentivity. And third one, coercivity. तीन टर्म है यहाँ पे. Unless until to allow the magnetic lines of forces to pass through the substance, it never becomes what? Magnet. उसको magnet बनना है, थोड़ी देर के लिए बनना है या long period के लिए बनना है, mu r should be there. So deciding factor to make the permanent magnet and electromagnet, retentivity and coercivity. So to make the material to be a permanent magnet, it should possess high permeability, high retentivity and high coercivity. पूरे high रहना. The material which possesses high permeability, high retentivity and high coercivity, then such materials are selected for what? Making permanent magnets. Are you getting the point? To make the permanent magnet, I need the three factors. One is permeability, relative permeability, retentivity and coercivity. The material to be selected to make the permanent magnet, it should possess high permeability, high retentivity and high coercivity. Are you getting the point? That is the importance of what? This magnetic hysteresis curve here. अगर आपको retentivity मालूम है, coercivity मालूम है, by knowing the retentivity and coercivity of the materials, we can select the materials for making permanent magnets or electromagnets. Then I come across electromagnet. Electromagnets. Electromagnets are obtained. Electromagnets are going to be obtained as long as the current is passed through the solenoid, so long as it acts as a magnet. When the current is going to be stopped, then it does not act as a magnet. As long as the current is passed through the solenoid, then it acts as a magnet. When the current is going to be made to be stopped through the solenoid, then it doesn't act as a magnet. It loses its magnetic property. Then such materials are going to be used as what? Electromagnets. The material used for making the electromagnet is soft iron rod placed in the solenoid. Electromagnets are the substance. As long as the current through the solenoid, they are placed inside the core of the solenoid, they act as a magnet. When the current is stopped, then they does not act as a, then they loses their magnetic properties. So how to get the electromagnet? Soft iron rod is placed in the core of what? Solenoid. If you pass the current through the solenoid, then the soft iron acts as a magnet. When you stop the current through the passing through the solenoid, then it does not act as a magnet, it loses its magnetic property. Then so it is called electromagnet. Right? To select the materials to make the electromagnets, first it should allow the magnetic lines of forces to pass through it. Then it must possess what? Permeability, high permeability. The remaining two things are low. For the permanent magnet, all the three are high. For electromagnet, it must possess what? High permeability. The retentivity and coercivity are low. Then such materials are going to be selected for making what? Electromagnets. Are you getting the point? एक बार glance करो क्या क्या है बोल के. Then I come across what? The next thing. right? What is the permanent magnet? The materials which retains the magnetic property for the long period, even though at room temperature, then such materials are called permanent magnets. The materials which retain the magnetic property as long as the current through them. If the current is made to be stopped to pass through them, then such materials do not act as a magnet. They are becomes what? Electromagnet. How to get the electromagnet? Soft and rod is placed in the core of the solenoid. To have the permanent magnet, the properties for the material, it must possess high permeability, high retentivity and high coercivity. For the electromagnet, the material should possess high permeability, the remaining two things, low retentivity and low coercivity. Now this is about what? The permanent magnet and electromagnet. This makes the end of what? Magnetic materials. Right? Then I come across the numerical sections. Then I give the list of formulas. Is it clear? Yes. Then I come across what? List of formulae. Whatever the formula we have derived, I come across list of formulae. Numerical section से पहले list of formulae, formulas. So first one, the magnetic field flux per unit area. It is also given by, so magnetic flux phi equals to second vector B dot vector A is equals to BA cos theta. Right? Then the third one, the magnetic field is also defined as the force experienced by the test pole M naught. Then fourth one, Coulomb's law in magnetism, the force of attraction or force of repulsion mu naught divided by 4 pi, product of the pole strength and inversely proportional to square of the distance between them. Is it clear? Yes. हम जो कुछ करें सो उसी को इधर यहाँ पे ला रहे हैं. Then the fourth one हो गया. Fifth one, the magnetic dipole moment capital M equals to M into 2L, where 2L is the separation distance between the two poles of the magnet. It is a vector quantity. Its direction is from south to north. Right? Then after that, the bar magnet is equivalent to solenoid. In that case, the magnetic field on the axial line is equal to mu naught divided by 4 pi 2m by distance cube, that is r cube, distance cube. On the equatorial line, it is found that equatorial line mu naught divided by 4 pi m by r cube, distance cube. The relation between them, B axial line is equals to 2 times the magnetic field on the equatorial line. Is it clear? Yes. Then after this, we come across the torque, that is nothing but the time period of a oscillating bar magnet 2 pi under root of I by mb, where I is the moment of inertia of a bar magnet, m is the magnetic dipole moment, b is the external magnetic field. अगर frequency होना पड़े तो उसको reverse कर दो. Then after that we have proved the torque tau equals to mb sin theta. It is a vector quantity. We can write in the vector form torque tau equals to vector m cross vector b. Right? Then after this, shall I go here? 11th one. The magnetic potential energy of the potential energy of a magnetic dipole U equals to minus mb cos theta 2 minus cos theta 1. For the single angle, U equals to minus mb cos theta. Is it clear? Yes. Then after this, we come across Earth's magnetic field. In that case, Earth's magnetic field BH equals to B cos theta, BV equals to vertical component B sin theta. The resultant magnetic field B equals to under root of BH square plus BV square. Then if you want to calculate the theta angle of dip, so tan theta equals to BV by BH, then which implies theta equals to tan inverse BV by BH. Correct sir? Right. इतना करने के बाद we entered in the field of what? Magnetic materials. Then the magnetic materials are classified diamagnetic, paramagnetic and ferromagnetic. अब पूरे property पढ़ने के बाद we have got the relationship between the susceptibility and temperature. So for paramagnetic Curie law, the magnetic susceptibility is inversely proportional to temperature, then magnetic susceptibility equal to C by T, that is called Curie constant for paramagnetic substance. For ferromagnetic substance, Curie West Law, the magnetic susceptibility is inversely proportional to excess temperature, that T minus Tc, where Tc is critical temperature. At a particular temperature, ferromagnetic substance becomes what? Paramagnetic, and that temperature is called critical temperature or transition temperature. Now this is called Curie West Law. It is modified form of Curie law. If I solve it, C divided by T minus Tc, where C is proportional constant, Curie constant. Is it clear? Then after this we come across what? Magnetic hysteresis, that is lagging behind the intensity of magnetization to the magnetizing field, is called magnetic hysteresis. Then we have learned the two terms, coercivity, retentivity and coercivity. Then the last thing we have come across what? Permanent magnet and electromagnet. The materials which retains the magnetic property for the longer period even though at room temperature, then such materials are called permanent magnet. To get the permanent magnet, we have to be placed the soft, that is nothing but ferromagnetic rod in the core of what? Solenoid. Then for electromagnet, the materials which act as a magnet as long as the current passes through it, then they do not act as the magnet when the current is made to be stopped through them, then such materials are called electromagnet. Soft iron rod placed in the solenoid act as a electromagnet. To possess the permanent magnet, the material should have high permeability, high retentivity and high coercivity. For the electromagnet, the material should possess high permeability and remaining to low coercivity and low retentivity. Is it clear? Now these are the formulas used in what? The whole topic. In the next session, we go for the numerical problems belongs to NCERT, almost all the NCERT numerical problems. Is it clear? Yes. I hope that you have understood the whole topic. आपको notes provide करते हैं, कुछ भी doubts है तो notes clear कर लेता. Shall I end the session? Yes. Thank you.